So let's try another example of an integral of a product of secants and tangents. Okay, you can either think of this as going down the list or trying to come up with one of those ideal derivatives. So the first choice would be to have a secant squared show up. Or if you're thinking about it the other way, maybe we could have an even exponent of secant. That's exactly what happens here. So following that advice, the first thing I'm going to do is peel off a secant squared. Okay, in this case, we're taking a secant squared of 2x. So I'm going to make sure I've got a 2x in there. Let's see what we're left with. Okay, I've still got another secant squared, and I've got a tangent. Okay, now because I have secant squared over here, my objective is to turn everything else into tangents, because this guy would then be the derivative of tangent. So let's see what we can do here. I need to use a Pythagorean identity to convert that secant squared. So I'm going to rewrite this as tangent squared 2x plus 1 times tangent 2x times secant squared 2x dx. So now everything over here is written in terms of tangents. Let's break this apart into two integrals. I have the integral of tangent cubed 2x times secant squared 2x dx. And I've got the integral of tangent 2x times secant squared 2x dx. Okay, now remember the whole goal was to have this guy be du. So if du is secant squared 2x dx, working backwards, that means somehow u is going to just be tangent of 2x. So let's work from there actually. If u, let me make space, if u is equal to the tangent of 2x, that means du is going to be secant squared 2x, but with the chain rule, I also need to multiply by 2. Okay, so du equals secant squared 2x times 2 dx. So let's actually solve that for dx. dx equals du over 2 secant squared 2x. So let's plug that in and see what that does to our integrals here. Okay, so our first one, the integral of tangent cubed 2x, that's going to become the integral of u cubed. And then I'm going to write secant squared 2x. And instead of dx, I'm going to write du over 2 secant squared 2x. Similar with this guy, I've got the integral of, instead of writing tangent of 2x, I'm just going to write u. And then this is going to be secant squared 2x times du over 2 secant squared 2x. So let's clean these up a little bit. The secant squareds cancel out. So I have 1/2 times the integral of u cubed du. And over here, the secant squareds cancel out. And once again, I just have 1/2 times, and this time it's u du. Those are very doable integrals using the power rule. So this is 1/2 u to the 4th over 4. And this is 1/2 u squared over 2. So in other words, u to the 4th over 8 plus u squared over 4. Okay, but I don't like to leave u in my answer. U was equal to tangent of 2x. This is going to be tangent to the 4th of 2x over 8 plus tangent squared of 2x over 4 plus c. And that's our final answer for this one. So again, just recapping what happened in this problem, we started with a product of a secant and a tangent. We noticed we could pull off a secant squared, and then we just aimed to turn everything into tangents, which is what we did with our Pythagorean identity. We did a u substitution, and then this is the answer we got at the end.